Hi, this is the last video on redox reactions. It's called how to balance redox reactions. So remember, when we talk redox, we're talking oxidation, reduction. Reactions using the half reaction method, that's the main part of this topic, the half reaction method in acidic solutions. We'll do acidic solutions and we're going to do basic solutions. So basically what's happening is, let's say I have an equation in front of me. For example, I have this one: manganese oxide plus manganese oxide ion plus an ion gives you a manganese 2 plus ion plus an iron 3 plus ion. When I'm looking at this, it is what I would call unbalanced. Right? And if I have an unbalanced equation like this, it's going to create a problem. How I know it's unbalanced? Have a look here. Can you see there? I've got oxygen, but if I look on this side, there is no O2. And if there's no O2 on both sides, then I can't consider this balanced. In fact, what I can say about this equation is that not only is it unbalanced, it is invalid. So the only way that we can do this is by actually balancing. So what a balanced equation would look like of something like this would be a manganese oxide ion plus hydrogen ions is going to give you iron ions, and then you're going to end up with manganese 2 plus ions plus hydrogen plus water plus iron ions. So I want to go from here to here. And the only way that I can do this, let's say for this section, is I can look here and I can see H plus ions. And I know from my definitions of acids and bases that if I've got a high concentration of hydrogen ions from the Arrhenius definition, then I've got acids. Right? And I've got this H2O here. And what these two things are doing is they're balancing out those oxygens. So we need to look at, how do I go from here to here? I want to go from the first unbalanced thing to the balanced thing. And what we're going to do is we're going to put everything into what we call an acidic solution. Now, each of these equations have quite a bit that's going on with it. So it might take you 9 to 10 steps to do the balancing for these types of reactions. So I would suggest you work through it, obviously, with the video, and you work through it with me. And then afterwards, I will obviously give you some sort of practice. So at this point, skills that you need is assigning oxidation numbers. You need to know how to write half reactions. And the way you're going to do that is being able to identify oxidation and reduction. And if you can do oxidation and reduction, then you should know what's an oxidizing agent or a reducing agent. On top of all of that, you also need to know how to write balanced equations, ionic equations, net ionic equations. And don't forget, with the half reactions, you also need to know how to balance them. All right. Again, from there, you need a knowledge of acids and bases. So you should know your list of common acids and bases, and you should also know how to identify from acids and bases conjugate acid-base pairs. So what we're doing now is we're mixing redox. We're taking redox reactions and we're linking them to acids and bases. So there's a clear link between the two. And if you don't have these skills, then this section is going to be something I would say would be impossible for you to do. So please make sure that you have a good idea of what's going on before you even start this kind of a video or move on from this point forward. If you haven't done any of the work before this point, or you don't understand the work before this point, then doing the next part of this video is actually of no use to you. You need to go back, or you need to come and ask for help. All right, let's look at the first example. Right, so the question we're looking at here, example 1, it says balance the following equation in an acidic solution using the half reaction method. And they've given you Ag plus NO3 minus gives you Ag plus NO. Alright, so when we know that balancing a redox equation is very different from balancing a normal equation. So when we do these types of questions, we must balance the atoms, and we must also balance the charges. So here's where things get a little bit hairy. So it's not just about balancing atoms like how we normally done. This is the normal way. But now we'll be adding a degree of difficulty. So we're going to use a step-by-step process that we have to follow. And as we work with those steps, it will unfold. So pay careful attention to what needs to happen. All right, so let's look at the first thing, number 1, or step 1 rather. So we know that if I'm looking at this type of equation, we know that it's redox, right? So if I know it's redox, I want to know which elements are getting oxidized, which elements are being reduced. So we need to find where is oxidation taking place and reduction. So that's the first step that we look at. Oxidation and reduction. All right, so when we look at oxidation and reduction, we need to make sure, the second thing here is I need to look at rules for assigning oxidation numbers. Right, once we've decided about the oxidation numbers, the next thing that needs to be done is we need to look at this thing and we need to assign oxidation numbers to each of the atoms. Alright, so if I'm looking here, I've got Ag plus NO3 minus gives me Ag plus NO. So now with my Ag, it's an atom, so I've got 0. NO3 here, I've got -2 and I've got 3 of it, so I've got -6. But I want my overall charge to remain -1, so that has to be +5. Ag1 plus is +1 and NO is -2, which means N must be +2. Right, so if I end up linking these two here, and I've got my Ag and my Ag1 plus, I can see that it went from 0 to 1. If it goes from 0 to 1, then that means that it's my oxidation number is going up, so it's being increased, which tells me that I have a loss of electrons. If I link up the NO3 ion and the NO, what I'll notice here is that I've got a gain of electrons. Right. And what I'm looking at here is I'm not just looking at the NO3 like altogether. I'm looking at the N and the N, because I look at the oxygens. I'm going from oxygens from the O3, I'm going to the O. It stays at -2 and -2, so that doesn't get affected by it. So that's something I'm not worried about right now. All right, so let's not forget, when we're doing these sort of things, and I just want to make a note here, is that don't forget that oxidation numbers are not the same on both sides, right? So, for example, they must be dependent on their conditions. For example, for this one here, ions remain ions with the charge of the ion. Does that make sense? So don't forget when you're doing this type of question, we must make sure that things balance out, because like I said, this would have been times 3, which would have been actually -6. And to balance out that, So don't forget those kinds of rules. Also, don't forget that if the oxidation number goes down, I have a gain in electrons, which means I've got reduction. And if my oxidation number goes up, I have a loss of electrons, and that means I've got oxidation. Right, so in this situation here, once you've sorted all of this out and made these decisions, that's step 4. Step 5 is you need to write down what happened with each section. So I know here that silver is oxidized and that the NO3 is reduced, NO3 minus. Right, so now the next step that you need to do is we need to write half. So step 6, we want half reactions. Right, so I want the oxidation half reaction and the reduction half reaction. So for oxidation, let's name this A. We're going to go Ag became Ag plus. And you can see what you'll notice now is that when I'm writing these out, I have no electrons at this point. And it's a little bit different for B, the reduction. We're not doing it the same as we were. Here I start off with NO3 minus, and I've got NO. So these are my half reactions without the electrons. So we're doing things a little bit differently. Right, what needs to happen now in step 6 over here with these half reactions? We need to look at each half reaction by itself in isolation. So at this step here, we start at step 6, we're going to balance each half reaction separately. Alright, we're going to balance each half reaction separately. And what we're going to start with is we're going to start with B, which is the reduction half reaction. I like to start with the reduction half reaction because it's usually the easier of the two. Alright, so let's start and have a look at what we've got here. So when we do this sort of thing with the reduction half reaction, the first thing that needs to be done, right? Let's say the first thing, we must balance all other atoms beside O and H. Alright, so let's have a look here. So I've now got NO3. I've got NO3 minus, and over here I've got NO. So the atoms that I have is just nitrogen and oxygen on both sides. I need to just sort those numbers out. I've got 1 and 3 here, and on this side I've got 1 and 1. Alright, so please, this is what the first thing we're doing is we're working with the atoms. So we're going to balance the atoms first. Right, so if I'm looking at this sort of thing, my nitrogen's balance. Great. So once you've sorted out that first step, you're going to do another step. The next step says you need to add H2O to balance the oxygen atoms. So everything that's O. And then you need to also at the exact same time, we're going to add H plus ions to balance out the hydrogen, which is an H. Okay, this is a new sort of thing. So what this means is that when I'm looking at this equation in front of me, this NO3 minus and the NO, notice that there is an imbalance of oxygen. So over here on this side, I've got, undo that. On this side, on the right hand side, on the left hand side, I've got 3. But on the right hand side, I've got 1. So I need to balance that out. So how we do that is we add H2O, which is water, to balance the oxygens, and we add H plus ions to balance the hydrogens. So if I'm looking at this now, notice here on this side, I have a deficiency of oxygen. So I need to get those oxygen numbers up. So what I've got here, I've got NO3, wait more here, NO3 minus, and I've got here NO, right? I need to add H2O, so I'm going to add in an H2O on the side where there is oxygen deficiency. So plus H2O is going to go on that side. I'll write down some rules now, and then we'll have a look. Right, so by doing that, remember, I still had this set up. Right, by doing that, I've changed my number of oxygens. My number of oxygens is now 2. All right, but that's not what I want. I want 3. So what I'm going to do there is I'm going to add in a coefficient there and make it 2H2O. By doing that, I've now got, by putting the 2, I'm going to balance the equation. So I've got 2 times 1 is 2, plus 1 is 3. So by balancing that water and putting a 2 in front there, I sorted out my oxygen situation. But now I have myself a hydrogen situation. So if I look here now, in addition to all of this, I've now entered in a hydrogen situation. There, I don't know what's going on. On this side, I have 4. But we know how to sort that problem out. They said in order to balance the hydrogens, I can add in H plus ions. So on the left-hand side, I'm going to put in H plus. But now I need how many? 4. So I'm going to say 4. So now I ended up with 4. So in this situation, I've now got a balanced equation. Okay, so let's just write down some instructions here. Right, the first thing is, I'm going to do it in another color. The first thing is we must add H2O to this reaction as it will balance out the oxygen atoms. All right, it's going to balance out the oxygen atoms. This H2O must be added to the side with the least amount or the lesser amount of oxygens, right? And we did that there, right? The second thing is we must make sure it balance the oxygens. Right, that means there must be the right hand side in terms of oxygen must be equal to the left hand side in terms of oxygen. Right, the next thing, we know by adding the water it sorted out the oxygens, but the third thing is that adding H2O also adds in hydrogens, right? By adding in those hydrogens, the next part is the other side must be compensated. The other side must be compensated by adding H plus ions. And here what we did was we added it in. Right? Can we see that? Even the second step over there, I can just make an arrow here. I did balance it. See, I put a coefficient of 2. So once that's sorted out, I need to make sure, in the last step here, is make sure that the entire equation is balanced. Balance the entire question. So that's what's happening now. So this is what my equation actually looks like once I've sorted that information out. Right, so that's step 6. Let's look at step 7. Right, with step 7, just gonna get another color here, sorry. In step 7, right, after the atoms are balanced, the charges need to be balanced. So after atoms are balanced, the charges are balanced. Right, now how we do this? Step 8, we must add electrons to balance charges. Okay, add in electrons. Now the concept of balancing charges is a new concept. It's a new idea. You've never seen something like this, so please make sure that you watch what's happening. Right. The first thing that needs to happen is you need to decide how much charge you have on both sides. Right, so we're going to do here, we're going to find the charge on both sides. Right, and remember, when we mean balance, what we mean by balance is I want it to be neutral. Right, find the charge on both sides. So what we're looking at here, I'm still looking at reduction. I haven't even looked at the oxidation yet. I'm looking at reduction. I've got 4H plus NO3 minus gives me NO plus 2H₂O. Okay, so when I'm looking here, I've got a 1 plus charge times 4, right? Over here, I've got a 1 minus charge, right? Because this is an ion. And can you see that this number here is the coefficient? Right, so I've got that sorted out, minus 1. And then on this side, I've got NO. Both of these are not ions, which means they must be neutral. So NO is going to be 0, and H₂O is going to also be 0 because they both are compounds. Right, so on this side, what I'm actually sitting with altogether, I've got plus 4 minus 1, which is plus 3. And on the other side, I've got 0. Now, can you see that the charges, there is an imbalance of charge. An imbalance of charge. So what we need to do is I need to compensate for that. So the second step that we're going to do, let's do it in another color. Alright, so the first step was we find the charge on both sides. There's the charge on both sides. Right, so that's number 1. Number 2, there's a lot of 1s and 2s here. The next thing is to get the balances on both sides to balance out. So I need the same amount of charge on both sides. Right, so what needs to happen is you need the same amount of charge on both sides. Right. The only way that can happen now is we need to add electrons. Right. So basically what happens is we can't minus anything. we can only add electrons to things. So when I'm looking at this, let me just reduce this a little bit. Right, I'm just gonna move up here. I need to cancel out the positive 3 on the left hand side, right? And I know that I can do that by adding in electrons, and electrons have a negative charge. All right, so all I'm going to do is I'm going to add electrons onto the side that needs it. So if I'm looking here, I've got on the left hand side, it's very positive. I want it to be completely neutral. So what I'm going to do is I'm going to say 3 electrons are being added there to the side of the reactants, and I'm left with something that looks like this. Right, now let's see how that works out. The first thing I've got here is I've got negative 3, right, as a charge. Here I know I've got 4 times positive 1, and over here I know I had negative 1. And on this side I had 0 and 0. So when I look at the overall charge here, what's negative 3 plus negative 1? That's negative 4 plus 4 is 0, which is also equal to 0. So can you see how now I have a situation that I have 0, or rather no charge, on both sides. Now guys, it's not always going to be 0. I don't always want to come to 0. What I want to do is I want the charges to be equal. The charges to be equal through the addition of electrons. Through the addition of electrons, because electrons have a negative charge. Right, so once that's sorted out, I can say the charges are balanced. Right, and we put a pin in that. So that's what the first equation looks like so far. So the reduction half reaction, the new reduction half reaction, is 3 electrons plus 4H plus ions plus NO3 minus gives me NO plus 2H₂O, and that is what we call a balanced equation. Makes sense? Now the reduction is done, we have to do the same for oxidation. So when you get to this point, we're going to start with, you would be seeing it better, we're going to start with A, which was oxidation. Right. With the oxidation, half reaction. Right. With the oxidation half reaction, same rules. The first thing, we need to balance atoms beside O and H. Right. So if I'm looking here, I've got Ag, which is going to give me Ag1 plus. So I've got something that is neutral and something that is an ion. But in terms of balancing, I've only got silver atoms. So what I don't have to worry about is I don't have to do that first step. Let's take that out. So it is not necessary for me to do the first step. And if I look at the second thing, I must add H₂O to balance the O's, and I must add H plus ions to balance the H's. But if I'm looking at my equation right in front of me right now, I will have noticed that there is no oxygen, so that is not possible. There is no hydrogen, so that is impossible. So now for the second time, I can't do the second step. Right, so now I need to look at if my if I look at my atoms right now, I've got one, I've got one Ag atom and one Ag 1 plus ion. One atom, one ion, so therefore the atoms are balanced. Right. Now let's look at the charges. Right, so let's check this out. So we're going to, remember, add electrons to balance charges. Okay, that's what we're looking at now. Right, so I've got Ag and I've got Ag plus. So this is on 0 and this one's on +1. So now I need a situation where I need to add in electrons. If I add in electrons here, I'm going to keep going and becoming more negative. But I don't want it to become more negative. Right? I want it to be neutral. So what's going to happen now is, if you look on this side, it's +1. So what do I need to add there to make it 0? I've got to add in an electron. So what I'm going to do is, choose another color. I'm going to say I'm going to add one electron. Add an electron. So now I've got Ag plus Ag1 plus 1 electron. Now if I look at the charges, that's 0. This is +1 and this is -1. And that kind of cancels out. So now I'm left with 0 and 0. So now that this is balanced, so here the charges are balanced. So now this gives me a rise to another calculation. I know that for oxidation, I've got Ag, which is Ag plus 1 plus an electron. Right, so now that it's balanced, I'm ready to combine with the half reactions for reduction. Since these two equations are fully balanced for both atoms and charges, I'm going to start putting the question back together. So when I'm looking at the situation, what am I doing? Right. When we are looking at the situation, what I have now in front of me is I've got that Ag gives me Ag1 plus an electron, right? And I've also got the 3 electrons plus 4 H plus ions plus NO3 minus gives me NO plus 2H₂O. Right, those are the two equations that I've got in front of me. Right, if I look here at these two equations, notice that in the oxidation, so for the oxidation here, right, oxidation here, I have here 1 electron, right? And for the reduction, there are 3 electrons. Right, so what I want to do is I want to make sure that in order for reduction and oxidation to happen, I need to make sure that these two numbers here are the same. Right, so the only way to do that is to multiply. Right, so to balance out the electrons, we must multiply to bring both to an equal number of electrons. Right, so the first one is I can't minus electrons. So the best thing to do is to work with the one with the 1 electron, which is the silver. So I'm going to take everything in the silver and I'm going to multiply it by 3. Right. And all I'm going to do is I'm going to distribute. So now I'm left with 3 Ag gives me 3 Ag plus 3 electrons. Now notice that the number of electrons, now that I have this, the number of electrons on both sides, number of electrons on both sides, oh, not both sides, both reactions is equal, both 3. Right, so all we've got to do is, the next step, right, we must add the half reactions. Let's add the half reactions and cancel out what appears on both sides. Right, so that's another step that must be taken. So now I've got 3Ag, which gives me 3Ag plus 3 electrons, and I've got 3 electrons plus 4H plus NO3 minus gives me NO plus 2H₂O. Right, now what do we mean by add the half reactions? What we must do is we must add the reactants together, and then we must add the products. Right, so when I'm looking at something like that, I've got 3Ag plus 3 electrons plus 4H plus NO3 minus gives me NO, let's put that in, 3Ag plus 3 electrons gives me plus NO plus 2H₂O. Right, so the last thing I need to do now, I need to cancel all of this stuff out. So I can see on both sides, I can cancel out here the 3 electrons and the 3 electrons. Other than that, everything stays the same. So once you've canceled out everything, the last step is that you need to balance the equation. And then you also need to balance the charges. So you must write down a final balanced equation. So if I'm looking at this type of an equation in front of me, I know for H, I've got Ag, H, N, and O. Oops. And on the other side, I've also got Ag, H, N, and O. So when I'm looking at this, I've got Ag, I've got 3 and 3. Hydrogens, I've got 4 here, and I've got 4 on the other side because 2 times 2. Nitrogens, I've got 1 and 1, and then oxygens, I've got 3 on this side and I've got 3 on the other side. Right, so I've balanced the equation. The next thing I need to do is I need to balance the charges. So on this side, I've got, I'm just going to do it in green so we can have a look here. With the Ag, I've got 0. Then I've got 4H plus, so I've got 1 plus times 4 of them. And then on the NO3, I've got minus 1. Great. So that's the first part. So in total, I've got plus 4 minus 1, which is plus 3. If I check the other side, I've got Ag 3 plus there. So I've got 1 plus and I've got 3 of them. Great. Then with the NO, I know that it is neutral and the H₂O is also neutral. So can you see that this belongs here? This comes down here. Right? Instead of me writing it out again. Over here, this comes down the, you should write it actually closer to each other instead of so far apart. And then that's 0. So in total, my charge on this side is plus 3. It's not 0 anymore. This is the charges being balanced. So this is what you need to show. You need to show that the atoms balance and the charges balance. Right? So this is what we called the section of how to balance redox equations using half reaction methods in acidic solutions. So I want you to get through this video, and then when you come to class tomorrow, then we can look at 2 other examples, and then you can watch the basic one, and then we're done. All right, so please make sure that you get this done.